What if one of the most advanced building materials of the future isn't forged in a factory, but grows in the ground? What if it's not mined or melted or poured, but sprouts like grass, strong enough to rival steel, yet light enough to bend in the wind? That material already exists, and it's called bamboo. For centuries, bamboo has already been used in homes, scaffolding, and bridges across Asia, South America, and Africa. But today, it's no longer viewed as just a local or traditional resource. Architects and engineers around the world are beginning to call it the steel of the future, a title that suggests bamboo may play a key role in reshaping how we build in the decades ahead. So, what makes this plant so extraordinary? Well, for starters, bamboo has an astonishing strength-to-weight ratio, making it strong enough to compete with conventional materials like steel and concrete. And at the same time, it's one of the fastest growing plants on Earth, capable of reaching full structural maturity in just 3 to 5 years. And unlike trees that need replanting after harvest, bamboo regenerates from its root system, growing back again and again and again. There are very few resources which combine strength with such speed and renewal. Bamboo's story isn't just about numbers and growth rates. Around the world, ambitious projects are proving that bamboo can form sweeping sports halls, schools, pavilions, and even museums. These structures reveal that bamboo isn't just a relic of the past, it's a symbol of modern innovation. Still, for all its promise, bamboo faces challenges that must be solved before it can become truly mainstream. To understand whether bamboo deserves its reputation as steel of the future, we first need to explore what gives it such remarkable strength and sustainability. So, bamboo's reputation as the steel of the future begins with its surprising strength. Although it's technically a grass and not a tree, certain species of bamboo can achieve tensile strengths of about 28,000 pounds per square inch, surpassing mild steel. Tensile strength is a material's resistance to being pulled apart, and bamboo's fibrous structure makes it exceptionally good at withstanding these forces. This means that bamboo can perform in ways many would just not expect from something so light and seemingly delicate. One of bamboo's great advantages lies in its strength-to-weight ratio. Steel is undeniably strong, but it's also heavy and very energy-intensive to produce, whereas bamboo, on the other hand, combines high strength with low weight, making it really easy to transport, handle, and build with. In earthquake-prone regions, this flexibility and low mass make bamboo structures safer, as they can absorb and dissipate the seismic energy without catastrophic collapse. This resilience has long been valued in traditional bamboo architecture across Asia and South America, and modern engineers are rediscovering just how valuable this can be. Equally impressive is bamboo's renewability. Where hardwood trees may take decades or even centuries to grow to maturity, bamboo can be harvested in just 3 to 5 years, depending on the species. Unlike trees, which must be replanted once cut, bamboo regenerates from its existing root system. When harvested correctly, the plant continues to grow new shoots without any degradation to the soil. This ability to renew itself rapidly makes bamboo one of the most sustainable natural materials in the world. In fact, bamboo is actually often cited as one of the fastest growing plants on Earth, with some species capable of growing nearly a metre in a single day under ideal conditions. This, frankly, remarkable speed not only ensures a steady supply of usable material, but also allows bamboo forests to act as efficient carbon sinks. During its rapid growth phase, bamboo absorbs large amounts of carbon dioxide, making it a powerful ally in the fight against climate change. Beyond environmental benefits, the combination of strength and rapid renewability positions bamboo as a highly practical solution to the world's building challenges. The construction industry is one of the largest contributors of global greenhouse gas emissions, particularly through the production of cement and steel. Substituting even a portion of this demand with bamboo could help reduce emissions, while meeting the growing need for affordable housing and resilient infrastructure. Bamboo also has a natural versatility that adds to its appeal. It can be used whole in its cylindrical form, split into slats, or engineered into laminated boards and beams that resemble timber. This adaptability allows bamboo to serve as both a structural material and a finishing material, bridging the gap between traditional craft and modern construction. Taken together, bamboo's extraordinary strength, lightness, flexibility, renewability, it makes it a compelling candidate for the title of steel of the future. It represents not just a building material, but a shift in thinking, an acknowledgement that the answer to sustainable construction may actually already exist in the natural world, waiting to be rediscovered and reimagined. While bamboo's strength and renewability make a compelling case in theory, its true potential comes to life when we look at structures already standing around the world. These buildings are not only functional, but they're works of art that demonstrate bamboo's power and versatility. One of the most celebrated examples is the Green School in Bali in Indonesia. This world-renowned campus is almost made entirely of bamboo, designed with sweeping organic curves and open-air classrooms. The school isn't just a place of learning, it's a lesson itself in sustainable construction. Its very form bends and twists in ways that concrete and steel struggle to achieve, showcasing that bamboo's ability to combine structural strength with its visual elegance. Thailand provides another striking case with its Bamboo Sports Hall. Completed in 2017, this hall uses bamboo trusses to span large distances without internal columns, creating a span that feels both monumental and just natural. The design is not only structurally efficient, but also environmentally conscious, using local, renewable resources to deliver just such a world-class facility. Vietnam has also become a hub for bamboo innovation. Projects like the Bamboo Stalactite Pavilion and numerous bamboo community centres are celebrated for blending modern engineering with traditional craft. These spaces highlight bamboo adaptability. It can be shaped into delicate lattice work or massive load-bearing elements, all while retaining a natural, organic beauty. Outside of Asia, bamboo has found its place in eco-resorts across Costa Rica, Colombia, and Africa, where it's used both for structural frameworks and atmospheric interiors. Temporary festival pavilions, such as those built for Burning Man and similar events, have also used bamboo to demonstrate how quickly and beautifully it can be assembled in large-scale installations. What all of these projects share is a willingness to push boundaries. Bamboo is no longer treated as just the poor man's timber or a stopgap material. It really is being recognised now as an architectural statement, a marker of innovation and ecological responsibility. These structures tell us that bamboo is not confined to tradition, but can rise to the level of contemporary design, competing with the very best of steel, of glass, and of concrete. By standing tall in these environments, bamboo buildings prove that this material isn't just about sustainability, it's about beauty, about culture, and the possibility of reimagining architecture from the ground up. The phrase "steel of the future" feels less like a metaphor and more like a reality when you walk through these extraordinary spaces. But despite its promise, bamboo has yet to become a mainstream global building material, and the reasons are worth examining. First, there's the issue of durability. Left untreated, bamboo is vulnerable to moisture, pests, and decay. While modern chemical treatments and design innovations can address this, they do add a cost to the complexity, making it harder for bamboo to compete with industrial materials. Secondly, standardization remains a hurdle. Unlike steel beams or concrete blocks, which can be manufactured to consistent specifications, bamboo grows in various sizes and qualities. Developing global building codes for safety standards and reliable certification systems for bamboo is an ongoing process. And another barrier is just perception. In many regions, bamboo is still seen as a material for low cost or temporary housing. Changing this narrative, convincing people that bamboo can be both premium and permanent, requires education, and high-profile success stories like the ones I mentioned before. And finally, supply chains kind of limit bamboo's scalability. While it grows abundantly in the tropics, global demand requires processing facilities, distribution networks, and investment in engineered bamboo products. These systems are emerging, but they're not quite yet widespread. The good news is that researchers and architects are addressing these obstacles head-on. Innovations like laminated bamboo panels and fire-resistant treatments and modular designs are steadily closing the gap. Bamboo may not yet be ready to replace steel everywhere, but the path forward to broader adaptation is clearer than ever. Bamboo's story is one of transformation. Once regarded simply as a humble plant or a material of necessity, it's now being reimagined as a cornerstone of sustainable construction. Its extraordinary strength, its unmatched speed of renewal, and its proven architectural beauty have earned it the bold nickname, the steel of the future. Around the globe, iconic structures already demonstrate what bamboo can achieve. From the flowing classrooms of Bali's Green School to the vast bamboo halls of Vietnam and Thailand. These projects don't just inspire, they prove that bamboo belongs on the global stage of modern architecture. Of course, bamboo still faces challenges like its durability, the standardization, the perception, and the infrastructure all stand in the way of widespread adoption. But every year, research and innovation bring new solutions. Engineered bamboo products, better treatments, and global awareness are steadily breaking down barriers. What makes bamboo's story so compelling is its dual nature. It's both ancient and futuristic, traditional and cutting edge. It represents not only a building material, but a philosophy. That sustainable answers may not lie in creating synthetic substances, but in rediscovering the power of nature itself. Whether bamboo will one day stand alongside or even replace steel remains to be seen, but its impact is already undeniable. As architects, engineers and builders continue to search for greener, stronger and more adaptable materials, bamboo shines as a symbol of what's possible when we let innovation and nature grow together. So the next time that you hear bamboo called the steel of the future, remember that it's not just a catchy phrase. It's a glimpse of how we might build a better, more sustainable world. I hope you liked that video. Click here to learn more about another material that's maybe stronger than steel and concrete in the form of CLT.